Hello, HL2 students. So in period 3 today, we did not get to the very last example, or we started it and we didn't finish it. So I'm going to do a video over that very last example on this sheet. So this is H3, which is the additional topics related to vector algebra. So we're going all the way to here, to example 4. All right, so this particular problem says that we have a vector d, which is -4, 3, and we could even draw a picture of that if we wanted to. So -4, 3 basically means I'm starting somewhere, I'm going back 4 and up 3, so it's going to look something like this, okay? So there's our -4, 3, and that's our vector d. And this says we want to find a unit vector u which goes in the same direction as d. So basically we're trying to find a unit vector, so it has to be only 1 unit long, and it has to go in the same direction as d. So there are a couple different ways that you can think about this, and I'm going to take you through sort of the more algebraic way first, and then we'll talk about it a little bit more geometrically, and eventually what we're going to do is sort of come up with some formulas for this. So if we know that we want this vector u to go in the same direction as d, that means that they are parallel. And we just talked about up here that if two vectors are parallel, then they have to be scalar multiples. So you can go back to your notes and look at that. So since they go in the same direction, we know therefore that vector u has to be some scalar multiple of vector d. Okay, so they're going to go in the same direction, it's just going to be a different length. Now, because we know it's a unit vector, all right, we also know that the magnitude of u is equal to 1. Okay, so we're going to kind of work through this a little bit. So we know that the magnitude of u is going to be equal to the magnitude of kd, right? And we know that the magnitude of kd is just going to be the absolute value of k times the magnitude of d. Okay, so now we also know that this magnitude of u is going to be 1. So we're just going to kind of work this through. So we know that absolute value of k times the magnitude of d. Now d is -4, 3, so let's sub that in. Has to give us 1. And the magnitude of d is going to be absolute value of k times the square root of, so we're going to have -4 squared, so that's 16, plus 3 squared, which is 9. That equals 1. So it looks like this is going to turn into, going up here, the absolute value of k times the square root of 25, which is 5, has to equal 1. So the absolute value of k has to equal 1/5. So remember, if the absolute value of k is 1/5, then technically that means that k would be plus or minus 1/5, right? Both of those values would work. However, it says it has to go in the same direction. So because it's going in the same direction, we just learned that k has to be positive. So k has to be positive 1/5. So we can say, therefore, I'm sort of running out of space. I'm going to come up here. All right, so therefore, we know that vector u is equal to, we just figured out that k is 1/5, so it's going to be 1/5 times vector d. So that's 1/5. Now vector d again is -4, 3. So that's going to be the vector -4/5, 3/5. Okay, remember when you take a scalar multiple, you have to multiply both of the components by the scalar that's out here. So there is our final answer. Now, and this is vector u. Now, I just want to point out, we can check this. The magnitude of u then is going to be the square root of -4/5 squared is 16/25, and 3/5 squared is 9/25. So that's the square root of 25/25, which is the square root of 1, which is 1. So it is a unit vector. And because k is positive, because it's 1/5, we know that it's going in the same direction as vector d. Now, I also want to point out that really what's going on here is that our vector d, we said, has a magnitude of 5. All right, we found that just a moment ago. All right, and then if I want a unit vector, a unit vector means a length of 1, what do I want? I want 1/5 of this vector. So we can even sort of think it through without even doing all of that work, that u has to be 1/5 of vector d, after we figure out what the magnitude of that is. So I want you to notice that this number that's down here is simply the magnitude of our original vector d. So if we want to come down here and write a general rule, we can say that a unit vector u that goes in the same direction as v, what we have to do is find out, well, okay, what's the magnitude of v? So here's our vector v. And then we want the unit vector, so we just want 1 over the magnitude of v times the vector. Okay, and you can verify that that's what we did up at the top. We took 1 over 5, why 5? Well, because that was the magnitude of d times the vector d. Okay, so we're just doing the same thing. All right, I'm going to stop and then I'm going to do a separate video for B and C.